Good morning. Sorry I can't be there with you all today, but you get an opportunity to learn how to solve systems of linear equations by using substitution, and I hope you will use this video to help you along. Let's start as if we were in class, and here is your warm-up. Pause the video, please, very quickly. Finish up this warm-up and check back for the answers. So as you will see in your answers here, we are going to be solving for a variable as well as using the distributive property today. So we're going to be solving systems of linear equations using substitution. You will see over the next several days that there are several different ways to solve systems of equations. Substitution will probably be your go-to method. So it is important that you learn how to do this today. All right, so an equation of a line has infinitely many solutions. What does that mean? Well, if I were to graph a line, you would see that there are an infinite number of points on the line. So there are an infinite number of solutions. But if I were to graph a second line here, you'll notice that there's only one point at which the two lines cross. Well, that point is a solution to both of these equations. We'll see more of that as we do graphing, but suffice it to say that we need to be able to find that one point. So if I have two linear equations, which I could graph on a graph like this, what we're trying to do is find that one solution where it solves both equations. So let's work on substitution. Y equals 3x. I know that anytime I see a value y, I could substitute it with 3x because these have the same value. So in this second equation here, instead of writing y, I'm going to write 3x. Then notice I only have one variable, and I can solve and find the value of that variable. Okay, let's solve. I see that 2x equals 4. I divide by 2 both sides, and I know that x equals 2. Well, if I know that x equals 2, now I can substitute that back into my original equation. Y equals 3 times 2, so my y equals 6. So the solution to this system of equations, these two equations, is an x value of 2 and a y value of 6, which I will write as an ordered pair. And I can check very quickly to see that that ordered pair works for both of these equations by substituting 6 in for my y value. So 6 equals 3 times, instead of x, I'll put in 2. And 6 does equal 6. And then I'll substitute my 6 in for my y in my second equation, the 2 for my x, and I will see that 6, again, equals 6. Let's try that again. So it's important to note that there are actually multiple ways to solve with substitution. What I'm showing you in this video is just one example. I could solve for x down here. I could solve for y. I'm going to choose this time to solve for this value of x. So I'm going to move my y over to the other side. So I know that x equals y plus 4. Well, then in my second equation, I'm going to substitute this value into my other equation. Instead of writing x, I'm going to write y plus 4. I'll finish up my equation, and then I can solve for y. 3y plus 4 equals 4. Subtract 4 both sides. 3y equals 0, therefore y equals 0. So I know what my y value is, and I could substitute my 0 back into either of these equations to find out what my x equals. Well, I'm just going to stick it into that first one. X minus 0 is my value for y equals 4, so that means that x equals 4. So the solution to this system of equations, these two equations, is the value, my x of 4 and my y of 0. And again, I can substitute these back to check to make sure that it is a solution to both. So plugging in on my first equation, I've got 4 minus 0 equals 4. That's true. I've got 4 plus 2 times 0 equals 4, and that too is true. So in fact, this is a solution to both equations, that ordered pair 4, 0. So I'm going to suggest that you write down this list of steps, and then it'll become more natural as you go along, but you'll have your notes to reference later if you need them. So we're going to solve for one variable in one of the equations, and we'll see later that we may need to do that more than once. But for right now, I had an equation like the last one, x minus y equals 4. I solved for x by moving the y to the other side. So that was my first step. My second step was to substitute that result into the other equation. Well, I took that value of x and I substituted that back into the second equation. So I had y plus 4 plus 2y equals 4. This is the problem from the last slide. So go back to your notes and look at this. Okay, then I'm going to solve the equation to get the value of that first variable. So I found out here that y equals 0. Okay. Then I substituted that value back into one of the original equations, and I substituted it into that first one. So I knew that x minus 0 equaled 4. So I found that x equaled 4. Then I wrote that answer as an ordered pair, x, y, and in this case that was the value 4, 0, and then I plugged in that value back into my two original equations to check that it was true. Okay, so again, I want you to remember that there are many options for solving. I am choosing one. It does not mean you have to solve it the exact way I do. I see, though, that I've got this lone y here without a coefficient, so it's going to mean a lot less division later and less fractions. So I'm going to solve for my y here, and I'll see that y equals 5 minus 5x. All I've done is solve for my y. Then I'm going to take this value, 5 minus 5x, and substitute it in for my value of y in the other equation. I cannot substitute back into this equation. I have to use the other equation. So I'm going to take that value and rewrite that to x minus 3, and I'm going to plug in for my y this value, 5 minus 5x, and that equals 19. Well, I'm just going to simply solve, 15 plus 15x equals 19. Then I have 17x minus 15 equals 19. So I have 17x equals 34, so my x equals 2. So I have the value of one of my variables. I'm going to plug that back in. So I've got 2 times 2 minus 3y equals 19. So I can solve for y. And my y is -5. So I know the solution to this system of equations is an x value of 2, a y value of -5. And again, I'm going to check that solution by plugging those values into both equations. 4 plus 15 does equal 19, and 10 minus 5 does equal 5. So this is in fact the solution to this system of equations. All right, here is another one. If you feel like you know what you're doing, go ahead and pause the video and work on it on your own, or follow along with me. Again, I like that I have that y that's all by itself, so I'm going to solve for y here. And then I'm going to take my y value and I'm going to substitute it in for this y. And I will solve for x. I have my x value, so I'm going to substitute that back into one of the equations. This time it doesn't matter which one. And I have the solution to this system, which is -1, 6. And again, my last step is going to be to substitute these values back into each of the equations to check that they are, in fact, the correct solution. So I've got 2 plus 6 equals 8. I've got -3 plus 12 equals 9. So I do have a correct solution. All right, so a real world application. And actually this really can happen. So let's take a look and compare two movie rental companies. I've got one with a $10 per month fee and a charge of $2 per movie. The other one has no monthly fee but charges $3 per movie. So notice I have no equations. I'm going to have to set these up by myself. So company one, I know that y equals that $10 per month fee, and I'm only looking at 1 month, so 10 is just my one-time charge, plus $2 per x will stand for the number of movies. So I've got 10 plus 2x for my first equation. In my second equation, y equals, there is no initial charge, but I do have a $3 per video charge or per movie charge for company 2. I want to know when, at what point I'll have the same number of movies will be the same cost. So I know that I want these two equations to be equal. Where are they equal? Where is that solution? Where will they cross? So I'm going to take this value of y and plug it into my other equation here for y. So I've got 3x equals 10 plus 2x, and this should be rather simple, I would hope, for you to solve. I see that the number of videos where the cost will be the same is 10. So I've got 10 videos. Now, what is that cost? Well, the cost is my y value. So I'm going to plug my 10 back in, and I see that for 10 videos, my value is $30. So my solution is, with 10 video rentals, both companies will cost $30. And again, I'm going to plug it back in just to check. And 30 does equal 10 plus 20, and 30 equals 30. So then the question asked, if my plan was to cancel after renting 50 movies in 1 month, which is the cheaper option? So what I'm going to need to do is plug in a X value of 50 because I'm going to have 50 movies and find out what my cost or Y value is going to be. So plugging into my first equation, that $10 initial, that monthly fee, plus 50 movies at $2 per movie, my cost is going to be $110. With Company 2's option, I'm going to get charged strictly for the videos, and for 50 videos at $3 a piece, that's going to be $150. So clearly, my best option is Company 1. So all I've done is I've taken that 50 videos and plugged it into both equations to see which one is cheaper. Although I do also know that with 10 videos, the cost for both is the same. One more real life example. I've got a cable television provider, and let's go ahead and set up our equations for these guys. My first cable television provider has a setup fee of $60 and then an $80 charge per month. And then my second company has a $160 equipment fee, and that's again just a one-time charge, and a $70 per month fee. So I want to know in how many months the cost will be the same. That's what A is asking me. So I know I want these two to be equal. So again, I'm going to take this value of Y, plug it into this second equation. 60 plus 80x equals 160 plus 70x. I'm going to quickly solve for x. So I know that x, my number of months, is 10 when they are both equal. So at 10 months, Cable Company 1 and Cable Company 2 have the same fee. So now I need to find out what that fee will be. Well, for 10 months, I'm going to plug it into either of those equations, and I'm just going to pick this first one since it's right there. My cost for 10 months is going to be $860. And of course, I'm double checking that I got the correct solution, so I am going to plug that 10 into the other one just to check to make sure that I got 860. So Y, and in fact 700 plus 160 is also going to get me 860. So I do know this is the correct solution. So they are the same at 10 months. That charge will be $860. So the second question asks, though, if I plan to move in 6 months, which one's my cheaper option? So I'm going to plug in my 6 months into both equations to see which one is cheaper. Well, my Y, or the cost of my cable, is going to be, in the first instance, 60 plus 80 times my 6 months. So that's going to be a total of $540. And for Company 2, my Y, or my cost, is going to be 160 plus 70 times 6 months. So that total fee will be $580. So obviously it is cheaper to use Company 1 if I'm going to be living there for just 6 months, but if I'm going to use my cable for 10 months, then the cost would be absolutely the same no matter which company I picked. So you have some worksheets to work on. I'm going to post another quick video to explain a couple of those problems. As well, you have some IXL and Con to work on for tomorrow, and hopefully I will see you tomorrow morning.